this video, we are going to see the definitions of the limiting reactant and percentage yield, and later we will perform some of the stoichiometric calculations using mole concept, including limiting reactant and percentage yield. Enjoy your learning! So today you are going to be a chef. We are going to do hot dog in bun. So in order to make hot dog in bun, we need to have buns and hot dogs. So in this case, we do have as much as 4 buns and 5 hot dogs. So in order to make this hot dog, since we only have 4 buns, meaning that these 4 buns only required as much as 4 hot dogs. So after we put this hot dog into this bun, you have successfully making 4 hot dog in buns. Okay, 4 yummy hot dog in buns. So we can see that at first we have 5 hot dogs. Okay, so after 4 we have been used in order to make this hot dog in bun, we have 1 hot dog left. Okay, we have 1 hot dog left over here. So this excessive hot dog is no more usable in order to make this bun. Okay, this hot dog in bun, because we don't have no excessive bun anymore. So it means that even though we have extra hot dog, but we can no longer make this hot dog in bun because we have the limited amount of bun. So in this case, the thing that limit the amount of hot dog in bun is actually this bun. So once this bun has fully consumed in the making of this hot dog in bun, so the production of this product is limited. Or we can say that we can make no more hot dog in bun after we have consumed all the buns here. Okay, even though we have excessive of the hot dogs, but still when bun has fully used in order to make the hot dog in bun, so the production of this product will be stopped. So the one that limit the production of this hot dog in bun is actually this bun. So generally, we can see that it is very important to know limiting reactant, because by knowing the limiting reactant, we can identify how much of this excessive reactant yang akan diguna pakai in production of the hot dog in bun. Because excess reactant or excessive reactant ini adalah berada dalam amount yang berlebihan. Okay, so we will not use all of them in order to make this hot dog in bun. Okay, but we will just use some of them sahaja. So how many some of them itu bergantung kepada this limiting reactant. So by knowing we have 4 limiting reactants here, so kita hanya akan pakai sebanyak 4 hot dog sahaja from this excessive reactant. And also, by knowing the limiting reactant ini juga is very important kerana kita boleh identify how much of the product that will be produced, okay, in the end process. Okay, daripada limiting reactant ini, you boleh tahu, okay, kita akan dapat sebanyak 4 hot dog in bun. Okay, and also you boleh tahu juga berapa banyak leftover of the hot dog. And now, let's apply this concept in chemical reaction. So in chemical reaction, we do have excessive reactant and limiting reactant. So the concept is just similar with the one we have discussed just now. So the importance by knowing limiting reactant in chemical reaction is that we could identify how much product, okay, that should be formed in the chemical reaction. So we can say that in chemical reaction, the formation of this product is actually depending on this limiting reactant, because limiting reactant, okay, akan tentukan berapa banyak produk yang akan terbentuk. So once limiting reactant has fully consumed in the reaction, maka production of this product will stop. Okay, no matter how many excessive reactant, apabila limiting reactant telah habis, maka production of the product pun akan terhenti. Okay, we can make no more products after we have fully consumed the limiting reactant. Okay, and also from this limiting reactant, we can also identify the leftover from this excessive reactant. We can calculate that as well. So that is the importance of the limiting reactant in chemical reaction. So now let's refer to our main concept, okay, which is in chemical concept. Apakah excess reactant, limiting reactant, and some other terms. Here are the important concepts in this content. The first one is limiting reactant. Limiting reactant is in limit amount in reaction. It will completely consume in chemical reaction, and there will be no balance at the end of the reaction. So limiting reactant is actually the reactant that limits the formation of the product, and chemical reaction will stop just after all limiting reactants have fully consumed in the chemical reaction. Apabila semua limiting reactant telah diguna pakai, maka chemical reaction akan stop dan kita takkan observe lagi dah any formation of the product. Okay, the second one is excess reactant. Excess reactant present in quantity excess than limiting reactant. Okay, it is also one of the reactant, tapi it exists in the form of excessive amount. And there will be balance of this excess reactant at the end of the reaction. The third one is theoretical yield. It is amount of product after all limiting reactants has reacted. And we can get the amount of this theoretical yield from calculation. The fourth one is actual yield. It is the amount of product obtained from actual reaction or experiment. And actual yield, the amount will be less than the theoretical yield. So what is the difference between these two? This is actually mass of product. They are actually mass of product. For theoretical yield, it is the mass that we obtain from the calculation, and for the actual yield, it is the mass we obtain from the actual reaction or experiment. The last one will be percentage yield. So percentage yield is the proportion of actual yield to theoretical yield. Okay, multiplied by 100%. The formula for percentage yield will be actual yield over theoretical yield times 100%. So do you still remember? How can we get this actual yield and theoretical yield? Yes, actual yield is obtained from the experiment, and the theoretical yield we obtain from the calculation. So how to get the mass of the theoretical yield from the calculation? We will get it from the ratio with the limiting reactant. So that's why in the previous discussion, we have mentioned that the importance by knowing the limiting reactant is that we can determine how much the product will be formed from the chemical reaction. So in order to find the mass of the product from that chemical reaction, we can find it from the limiting reactant. Okay, we can relate with the limiting reactant. So these are the importance of limiting reactant in chemical reaction. So by knowing the limiting reactant, we could identify number of moles of excess reactant, number of moles of product, mass of excess reactant leftover, okay, mass excess reactant yang berbaki, mass of the products, and lastly the percentage yield. So in this case, apabila kita ada satu chemical reaction, so what you have to do first adalah you must find this limiting reactant. Okay, the very first task adalah you must find or identify which one is the limiting reactant. Because by knowing this limiting reactant later on, you could find each one of these values. how to find limiting reactant in chemical equation or chemical reaction. So these are the steps that can guide you in order to find the limiting reactant. So firstly, you need to find number of moles of both reactants. Okay, so please bear in mind, untuk kes di mana kita boleh cari limiting reactant adalah di mana dalam satu chemical equation tersebut mempunyai sekurang-kurangnya 2 reactant. Okay, so A plus B forming C. So kalau ada 2 reactant macam ni, maka you are possible to find which one is limiting reactant ataupun excessive reactant. Tapi kalau kita ada satu reactant sahaja seperti ini, so untuk kes yang macam ini, there will be no limiting reactant. Okay, untuk kes 2 reactant, yes, we can find limiting reactant. Okay, so in conclusion, untuk kes yang melibatkan 2 reactants and more, okay, you are able to find the limiting reactants. Okay, so let's see the steps. The first step is to find number of moles of both reactants. So for each A and B, you need to find their respective their respective number of moles. Okay, so mass of these two maybe will be given in the question. So from the mass given, okay, from the mass given, you have to find their number of mole and label their mole as available moles. So that is the first step. Second step is choose one reactant and assume it as limiting reactant. So antara A dengan B ni, kita tak tahu lagi siapakah yang the real limiting reactant. So what we can do is choose any one of A or B sebagai limiting reactant. Okay, assume dia dahulu sebagai limiting reactant. Okay, step 3, identify the real limiting reactant and excess reactant. And finally, you will use this limiting reactant to identify other mole of substances dan juga other mass of substances. Okay, so now let's do this together. Carbon tetrachloride CCl4 was prepared by reacting 100 gram of carbon disulfide CS2 with 100 gram of chlorine according to the chemical equation or reaction. Okay, so suppose that we have this chemical equation. So every time you have chemical equation in your question, please make sure you check for the balancing dahulu. Okay, check for the balancing. So here we have 1C, this one is 1C, and then 2S, here also 2S, and for chlorine we have 6 chlorine here, so 4 plus 2, 6 chlorine. So this equation has already balanced. Okay, so which method to be used to balance this equation? If you still remember, yes, it is inspection method. Okay, I used inspection method just now. Okay, so what we have in this question is we have these 2 reactants with their respective mass. So berapa mass of that reactants? We have 100 gram of carbon disulfide and 100 gram of chlorine. Okay, so by having this mass, apa yang kita boleh buat? Ingat balik langkah yang pertama tadi. You boleh cari number of mole of reactant dan labelkan sebagai N available. Okay, labelkan sebagai N available. So from the mass given in the question here, you are able to find its number of mole. N apa? N available. Okay, so next, calculate the limiting and excess reactant and percentage yield of CCl4 if 65 gram of CCl4 was obtained from the experiment. Okay, now we have this mass in the question. Okay, mass untuk siapa? Mass of CCl4. So mass that given in the question is actual mass. Okay, mass that given in the question is actually actual mass. Why? Because this mass is actually taken from experimental data. Okay, because this mass, okay, is taken from the experimental data. Okay, so now we will try to find which one is limiting and excess reactant, and lastly, we will find the percentage yield of this product CCl4. Okay, now let's do this together. In order to find limiting reactant, we will refer to this guide. So the first step is we need to find number of moles of both reactants and label it as available moles. So from the question given, okay, we already have mass for respective reactants. So from the respective mass given over dengan molar mass of respective compound, maka you akan dapat their molar mass. Okay, and label this molar mass sebagai available moles. Okay, available number of moles. So step 2, choose one reactant and assume it as limiting reactant. Okay, so what is our chemical equation? So according to this chemical equation, so we have these two reactants, and now let's assume CS2 as limiting reactant. Okay, ini baru assume bukannya betul-betul lagi CS2 as limiting reactant. Kita assume sahaja dahulu. Okay, so assume that CS2 is the limiting reactant. So ingat balik, kalaulah CS2 ini adalah limiting reactant, bermaksud we can identify how much of this excess reactant yang akan diguna pakai. Okay, so in this case, by using this ratio, you are going to find another number of mole of Cl2. Okay, kerana CS2 adalah limiting reactant, kita pakai ratio perkadaran between 1 and 2 over here to find the new moles of Cl2. Okay, number of mole yang baru untuk Cl2. So, masukkan nilai number of mole available of CS2. Okay, so from here, masukkan di sini. Okay, so N ni yang kita nak cari yang baru. N Cl2 yang kita nak cari yang baru. And then, kita buat darab silang. So you akan dapat number of mole yang baru untuk Cl2 will be this one. Okay, labelkan mole ini sebagai needed mole. Okay, labelkan yang ni sebagai needed. Alright, now compare. Okay, step number 3, identify the real limiting reactant and excess reactant. Macam mana? Nak cari the real limiting reactant adalah you have to compare. Compare apa? Compare N needed with N available. Okay, now N needed for Cl2 in this reaction is 3.9369. Okay, this is the amount needed in reaction. But in real, available amount kita hanya ada 1.4. So yang available means sedia ada. Available sedia ada 1.4. Tapi kita nak 3.9. So cukup tak? The answer is insufficient. Kita nak, yang kita perlu 3.9. Tapi yang kita ada available ada 1.4 sahaja. Bermaksud, okay, Cl2 ni adalah in limited amount. Okay. Alright. So we need as much as this number of mole, but we only have this number of mole. Bermaksud Cl2 ni, amount yang kita nak pakai itu lebih banyak daripada amount yang available. So in this case, Cl2 is the real limiting reactant. CS2 is excess reactant. Okay, chlorine is real limiting reactant. CS2 is excess reactant. If the amount needed is more than amount available, it is limiting reactant. If the amount needed less than amount available, it will become excess reactant. In question B, you are going to find the percentage yield of CCl4. So in order to find the percentage yield of CCl4, it is actual mass over theoretical mass times 100%. So from the question, we already have this actual mass. So next, in order to find this percentage mass, we need to find the theoretical mass first. So how do we find this theoretical mass? Do you still remember? We will relate with limiting reactant. So this is one of the important of knowing the limiting reactant, because by knowing the limiting reactant, we can identify the theoretical mass of the product. So what you have to do first is you have to write the ratio between the limiting reactant and the product CCl4. So according to our balanced chemical equation, 3 mole of Cl2 is equivalent to 1 mole of CCl4. So for the chlorine, this is its available number of mole, okay, and we are going to find number of mole of CCl4 over here. So to find the value of NCCl4, you akan buat cross darab macam ini, and we will get this number of mole of CCl4. Okay, so by knowing number of mole, definitely we can find the mass of CCl4. So by using the formula of N times molar mass of CCl4, you will get its mass. So this mass is theoretical mass. So after that, we will insert those values into our formula times 100%. So please make sure the unit of actual and theoretical must be similar. If they are in gram, so both of them must be in gram. If you are going to use kg, so both of the unit atas and bawah must be in kg. The unit must be setara, sama. So by doing these mathematical operations, so you will get the percentage yield of CCl4. 10 gram of zinc are added into 50 ml hydrochloric acid solution with a molarity of 0.2 molar to form H2 and zinc Cl2, hydrogen gas and zinc chloride. Write a balanced chemical equation. So in this question, okay, you should identify how many reactants and product do we have in this reaction. So obviously, kita ada sebanyak zinc and HCl ini sebagai reactant, zinc and HCl as reactants, and H2 and zinc Cl2 as the products. So what you have to do is you have to balance this chemical equation later on. And for question B, calculate the amount in mole of hydrogen gas produced. You are going to find how many or how much of this product produced from this chemical reaction. So in order to find the products, okay, you can refer back to the reactants. So how many reactants do we have in this chemical equation? The answer is 2. So by having at least two reactants over here, meaning that it is compulsory for you to find limiting reactant. Okay, so why we need to find the limiting reactant? Because kita nak cari, okay, mass ataupun mole of the products di sini. And for question C, calculate the amount in mole of excess reactant remains after the reaction is complete. So for question C, you are going to find the leftover of the excess reactant. So to know how much excess reactant left after reaction has completed, of course, once again, you need to find the limiting reactant first. So if you can see from this question, it didn't mention to you at all tentang limiting reactant. Okay, tapi you have to faham daripada soalan B dan juga soalan C. Okay, since you are going to find mole or amount of hydrogen gas, which is product, dan juga excess reactant left over. So you really need to have the limiting reactant here. So your first step should be finding the limiting reactant. Okay, so I hope we have ready with your pen and paper, and let's try answering this question together. So from this comparison, we have identified that the amount of zinc needed is less than the amount of zinc available. So in this case, we can conclude that so this is our real limiting reactant. The one that you did in the previous slide is the assumption of the limiting reactant, but now you have found out your real limiting reactant. So from there, by knowing the limiting reactant HCl, we can find the number of mole of hydrogen gas. So by writing its ratio, so this is the amount of mole of hydrogen gas that we obtain from the relationship of H2 and limiting reactant. In question C, you are going to find the excess reactant left over. So our excess reactant is zinc. So you are going to find the leftover ataupun baki of zinc reactant. So since we have found our limiting reactant that is HCl, so by doing the ratio between zinc and HCl, you are going to find the needed amount of zinc first. Okay, so what is needed amount of zinc? Needed amount of zinc is actually the amount of zinc that will actually be consumed in this chemical reaction. So this is the amount of zinc needed in this chemical reaction. So in order to find the leftover of the zinc, so what we have to do is we have to minus the available of zinc with needed of zinc. Let's try this together. In one process, 637.2 gram of ammonia are allowed to react with 1142 gram of carbon dioxide as equation below. So these are the reactants and these are the products. So before you proceed with the calculation, please make sure you check for this equation balancing first. Okay, and then you have to find for soalan A, which one is the limiting reactant. So how to find the limiting reactant? If you can see in this question, you have been given these two mass values. We have mass of ammonia and also mass of carbon dioxide. Okay, so and those are the mass for the reactant. So by having the mass of the reactant, of course you could find its number of mole, and then you proceed with our steps, do the comparison, do the assumption and so on to find the real limiting reactant. And then for question B, how much of the excess reagent in grams is left at the end of the reaction? So for question B, you are needed to find the leftover of this reaction, okay, leftover from the excess reagent. So meaning that you have to identify dahululah, okay, between these two, which one is the excess reagent or reactant. And then for question C, calculate the percentage yield of this compound. So this is actually the product. If the mass obtained from the experiment is 1000 gram. So what is this 1000 gram belongs to? If you still remember, again, in our previous example, the mass of the product that given in the question is actually the actual yield, okay, ataupun actual mass, because this mass is actually obtained from the experiment. Okay, so by having all these informations, maka you will be able to answer question A, B, and C. So you may pause for a while and please take time to answer all these questions by yourself, and later on you can check the answer in the next slide. Titanium is prepared by the reaction of titanium 4 chloride with molten magnesium between 950 degrees Celsius and 1150 degrees Celsius as equation below. So these are the reactants and these are the products. So please make sure you check for the balancing before we proceed with the calculation. For question A, if this mass of TiCl4 are reacted with this mass of molten magnesium, calculate the theoretical yield of titanium in grams. So in this question, you have been given the mass of the two reactants. So definitely, if you have mass of the two reactants or anything that could lead you to find its number of mole, so what you have to do next is you need to find their available number of moles. Okay, find their available number of moles, and then you proceed with do the assumption and do the comparison to find the real limiting reactant. So after you found the limiting reactant, so next you can do the ratio between the limiting reactant and the product to get the mass of the product. And then for question B, calculate the percentage yield if this mass of titanium are actually obtained. So again, titanium is the product, and the mass given in the question is the actual mass or yield. Okay, so by having this information, you will be able to calculate the percentage yield of titanium.
Thank you for watching, everyone. I hope this video could help to enhance your understanding in chemistry. Have fun in your learning, and remember, chemistry is easy and fun.